Hello, everybody. Welcome to Data Umbrella's first webinar for 2024. I'm going to do a brief introduction, and I will give the microphone and screen share over to Joe, and then we'll open it up for Q&A. So you can put questions in the chat as you have the questions, and we'll answer them at the end of the webinar. This webinar is being recorded. A little bit about Data Umbrella. We're a community for underrepresented persons in data science, and we are a nonprofit organization. This is the Data Umbrella team that makes the magic happen behind the scenes. We thank you for helping to make this a welcoming, friendly community for all of us. There are various ways to support Data Umbrella. The first and foremost is to follow our code of conduct and make it a community where people want to keep returning to. If you can share Data Umbrella events with other people in your network, that would be great. We'd really appreciate it. And if you want to contribute to Data Umbrella, we have a lot of projects that are open source. One of them is the video timestamps. So we do timestamps of all our videos. It helps people find the videos on YouTube. As well, we have a website that's open source. We have sprints that we've done with scikit-learn and PyMC. We have a blog that's open source, and we have an events board. If you are able to in your budget, if you'd like to support our nonprofit, we are an open collective as Data Umbrella. And if you work for a company that uses Benevity, whatever donation you make, your company will match that dollar for dollar. If you want to subscribe to the Data Umbrella YouTube channel, we have over 100 videos. We focus on data science, Python, RStats, open source, and career development. We have a lot of playlists. One of them is career advice. Another is data visualization, contributing to open source. We have a series for scikit-learn, PyMC, and NumPy as well. We have a monthly newsletter. We're at dataumbrella.substack.com. We only send one email a month, so we promise not to spam you. This is a QR code. So this is our most popular links. So Meetup is a place to go to sign up for upcoming events and find out what's happening. YouTube is where the videos are. The newsletter I mentioned. GitHub is where our open source projects are. Open Collective is where you can make a donation. Job board is where job postings, you can post them for free. And we are on other social media platforms as well. We use Big Marker for this webinar, and at the very top, you'll see CC, which means closed captioning. So if you'd like a live transcript at the bottom, just click on CC. We also have an online suggestion box, and I'll share the link in the chat. So if you have any suggestions for future event topics, if you have any feedback on this event, if you encounter any technical issues, to let us know. And if you have any other feedback, if you would like to speak at one of our events, let us know. Our next event is on January 23rd, which is 2 weeks from today, and it is a sneak peek at PenPot. The 2.0 release is coming out this month, and PenPot is the open source design tool. So if you've heard of Figma, this is the open source version of it. Today's talk is, what is machine learning security anyway? Super, super important. Our speaker is Joe Lucas. Joe is a senior offensive security researcher focused on AI at NVIDIA. He's the founder and chair of the NumFocus Security Committee and is a member of the Jupyter Security Council. He was one of the architects and hosts of DEF CON 30 AI Village Capture the Flag competition and is passionate about machine learning security education. Just a moment. Okay, I'm just going to go on. He holds a master's degree in computer science from Georgia Institute of Technology and a bachelor's degree in mathematics from the U.S. Military Academy. And his first open source contribution was as part of a Data Umbrella sprint for scikit-learn. Great. And with that, I am going to turn off my screen share and hand it over to Joe.
Thank you, Reshma. So today we'll be talking about the security of machine learning systems. I approach this from my professional work on an AI red team. And for those not familiar, a red team is an adversarial element. So we take the approach of someone who might be attacking a system in order to improve its defenses. And so if something is framed as if the attack is good, that's because that's the direction I work. But really, it's all to improve the security of these systems. We'll be focused on evaluating the security of a machine learning model or a machine learning system, not applying the machine learning techniques to classic cybersecurity problems. Just to make sure everybody is starting from kind of the same background or terminology, I'll probably be using the terms AI and ML, or artificial intelligence and machine learning, interchangeably. And a model is a binary. It's a tool for turning input data or features, which are numbers, into output predictions, which are also numbers. You know, we could be talking about classifiers or regression models or generative AI. And those are all still taking input numbers and turning output numbers. These systems are architected different ways, you know, with different mathematical components that you might use depending on your problem. When we talk about training, that's finding patterns in training data to minimize a loss function. So we're taking input data, building a function to approximate the thing we want, and measuring that through a loss function. And when we talk about inference here, that's an overloaded term. It means different things in different academic disciplines. But here it means taking the thing we have trained, the function we have trained, and using those patterns to make predictions on new data. So, you know, using the deployed system. When we talk about the security of AI, it's not magic. These machine learning components, they're just software components, and the software security industry is relatively mature at this point. We should still be applying all of those principles. And when we talk about training data, that's just data, and plenty of data protection rules, regulations, and best practices still apply. In security, you may hear of the CIA triad, and that stands for confidentiality, integrity, and availability. So at the highest, most abstract level, security teams are trying to ensure that their products are maintain the confidentiality that maybe the customers expect, that the integrity of the system is not modified, and that the system is available. And we can apply those concepts to machine learning as well. So we may want to keep a model confidential. We want to prevent an attacker from extracting it or distilling it. We may want to keep training data confidential to prevent attackers from learning what data the model was trained on. And we may want to keep user queries confidential so that they can't be read through something like a side channel attack, for instance. Moving to integrity, we want to ensure that the model predictions have their integrity maintained, that they haven't been modified through adversarial examples or something out of distribution. The model weights, all of the parameters that we learned through training that make up this complex mathematical function. We want to make sure those weights, the integrity is still maintained, that there haven't been attacked through training data poisoning. And if you're building this to represent a company or some other kind of organization, you want to protect the integrity of that reputation. It is possible you could, a model could be attacked such that the reputation is undermined. And finally, you want to make sure it's available to all the users. And so an attack that denies service or increases the latency to an unacceptable level attacks the availability of a system. When we use adversarial techniques to assess the security of a system, we often talk about a threat model. It's important to kind of understand why an attacker may be interested in undermining a system so that we can improve the defenses. And a common technique for doing that is the STRIDE method. Those form the first letters of spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privileges. These are various threats to a system. And those apply in the traditional security domain. Likewise, they apply to the machine learning components of a system, as shown here on the right. So someone may spoof an image to evade a facial recognition system. They may tamper with training data, or they may use training data leakage to disclose some sort of information that was not intended to be disclosed. So what's different about machine learning security? Why is it it's currently treated as maybe a distinct discipline or subdiscipline within security? Because there are new things that traditional security teams may not be equipped to deal with. There are training data issues, that data can be exposed to the model or that it can impact the model in new ways. Models may behave non-deterministically, so they may exhibit some probabilistic or semi-random behavior, and sometimes that's very hard to test reliably or to make assurances about the behavior of. In traditional security, we often talk about patches. So there's a vulnerability, someone changes a couple lines of code to make sure a buffer is sanitized, for example, and they can push the patch and the new version of the software is more secure. Models are more difficult to patch, and we'll talk about that later. And then, as you'll see in this presentation, the exploitation or attack techniques are new and sometimes very academic or mathematical or complicated. Patching machine learning models. So when we talk about there's software development life cycles, there's kind of should be a similar life cycle for maintaining AI products. And once you've deployed or finalized the system, there may be reasons why you wish you could patch it. So there's GDPR, which includes things like a right to be forgotten. So if a model is trained on my data and 10 years from now, I request to be removed from it, how can that happen? How can a company remove my data from their model? And maybe an even harder question is how can they prove to me or provide auditability for that removal? Maybe they've deployed a system and when they are using it, they learn that it has some bias against a class that's really undesirable. It wasn't represented in their training data, and they don't want to continue having a product with that kind of bias. How can they patch that sort of bias out? And how can they defend against new attacks? Really, today, there's some research about more tailored patching, but it basically boils down to retraining a model. And for some of these large foundation models that we've seen emerge, that can be a very expensive proposition. And so moving security processes earlier into the development cycle can help reduce these sorts of patching costs later on. We're going to talk about some, mathematical techniques to evaluate the vulnerabilities in these systems. But basic security still applies. And so you could perform 60,000 queries against a production API to try and extract or steal or build a functional equivalent of a model. Or maybe you could find that model on an open S3 bucket. And so as you're developing these things, you should certainly be considering some of the advanced techniques we'll talk about, but you should also ensure that you're following existing security best practices. I'm going to go over 3 things that you should keep in mind. These are if you take nothing else from this talk, please take these 3 things. Rule 1, as most data scientists should be familiar with, is garbage in, garbage out. The model only, quote unquote, knows everything that's kind of contained in its training data and those labels. And so if you don't have good fidelity or confidence in that training data, that represents a risk in the final product. Rule 2, which I violated while describing Rule 1, don't anthropomorphize. We talk a lot about artificial intelligence, but you're not teaching AI At the end of the day, this is a complex mathematical function with inputs and outputs, and it's static. And the more concrete you can keep that idea in your head, the more you'll be able to perform well-principled security work. And rule 3, the model context matters. So a model is just a binary mathematical file that's incorporated into a larger application or system. And based on that context, some of these attacks may matter more than others, and some may not matter at all. AI security has kind of a long storied academic history, exploring data and training and how it's processed and how it may be attacked to do a lot of different things. You can find papers regarding all of these topics on arXiv. And it's been going on for 20 years. And it's evolved and it's improved. And in security, we talk a lot about cat and mouse games, where an attack is developed and then a defense to mitigate that attack is developed, and then a new attack that evades that defense is developed. And that's been happening for 20 years, and they've gotten a lot better and more mature. But we haven't seen these sorts of developments really make their way into production systems yet. It's still been largely academic. And the vulnerabilities from 20 years ago are still largely in play, which may not be true for like traditional cybersecurity vulnerabilities. This is maybe the most canonical ML security example, and it's called adversarial evasion, or generating an adversarial image. And so if we take a look at the bus in the top left, and we've trained a model that does image recognition or image classification of buses, and we pass it through that model, it'll tell us with high confidence that is a bus. But then if we add some noise, some very small perturbations to the pixels that are imperceptible to humans, and we add it to that bus and generate the image on the bottom left and pass it through the exact same model, now we can get a very different, very wrong classification, in this case, an ostrich. And so it's the generation of that noise you see kind of on the middle left of the screen that is the adversarial attack. And so this goes back to rule 2. A convolutional neural network does not work the same way of the mechanics of a human eyeball, an optic nerve, and brain. And so the way it processes the bus in the top left and the bus in the bottom left is very different from the way your eyeball may. So that's cool. It makes a lot of waves. It generates a lot of interest in the field, but that attack has some limitations. Developing it is a very iterative process, developing the right kind of pixel mutations. You generate this per image, so it's not, it doesn't generalize very well. And it requires pixel level manipulation of an image. I need to be able to make the very top left pixel, a little bit darker in the red space, etc., for the entire image. And when we talk about, so that makes sense for a model and attacking a model, but remember what we normally care about is the security of an entire system, the deployment context. So what about like a camera? When an image or something passes through a camera to create an image, you're not going to have pixel level manipulation ability across that entire image. So how do you kind of perform the same sort of evasion attack in the real world? Those are called physically realizable adversarial attacks. So in the top picture here, there's a segmentation model trained to identify humans, and the individual standing in the middle is wearing some sort of sweater, and the design on that sweater made the model not segment that individual as a human. On the bottom, they created this little sticker, and if you put the sticker next to a banana, it changes the image classification from very confident it's a banana to very confident it's a toaster. And so these are examples of physically realizable evasions. The same concept from the previous slide applies, but now instead of pixel level manipulations, we've moved into the real world. These are very finicky and not incredibly reliable, but it's an evolving field. So if the individual in the sweater turned 45 degrees or was standing behind one of those desks where it covered up some of the sweater, that attack may not work as well, and they may get identified as a human. So when we talk about performing these attacks, we think through attacking an entire system, not a model. And this is really important. And I think as people are building and training machine learning applications, as data scientists and machine learning researchers, we think a lot about the model. And I would encourage you to, as early as you can in the process, think about the context in which that model will be deployed to understand various failure scenarios. Moving on from evasion is this concept that models are compressed versions of their training data. And so users with legitimate access to a model who can get predictions out of a model can maybe learn something about the data that model was trained on. So the first concept is model inversion. So we put a lot of various input through the model to try and get a sample back out. So that's the picture on this top left. We want to learn about the model, and the ideal would be extracting the picture on the far left. When we do this attack in real life, you might get something more like on the right. And again, this goes back to context. If you look at the picture above softmax, is that a good enough inversion for an attacker? Maybe if you're attacking a facial recognition system, it's not, but maybe it is enough to just know, hey, I still exist in this model. My training data was still used, because that's obviously a picture of me. And so the context is very important. A slightly easier attack to implement would be membership inference. And that's simply saying, is this sample, this example, in the training data? And what it really uses is the fact that these models are functions fit to their training data. And so if you give it a piece of training data back, it'll be very confident about the label of that training data, because that's what model training does. And so now if you give it a picture of yourself and it says 99%, you're like, oh, I was definitely in that training data. A final attack here is model extraction. And extraction is kind of like a nice way to say stealing, or stealing a proxy of, or approximating. And so, an organization may spend a significant amount of resources training some really cool model. And if an attacker can steal it or extract it, then for much cheaper, then that's undesirable. So they might just be able to grab it out of a bucket, or through a traditional kind of hack where they gain access to a data store and can literally copy the binary. Or with access to an API, maybe they can make tens of thousands of queries, which are used as labels to train a copy of the model. To mitigate this, it's what we call defense in depth. There are a lot of little steps you can take that all together improve your defensive posture, but it's hard to fully prevent it. So you may want to limit the output of your application to just the labels. So if it's a classifier that classifies images as either cats or dogs, you may just want to output cat or dog instead of 90% cat. The more information you give the attacker, the fewer number of queries it will take them to extract your model. So the easier it'll be for them. This will involve, again, tens of thousands of queries, probably, depending on the model. And so just rate limiting is a great defense, because you can really increase the amount of time it would take them. And then once you are logging their queries, maybe you can measure a certain progression of queries that's likely to signal that they're trying to extract your model. So everything we talked to up until this point had to do with inference time attacks, attacks against deployed production systems through access to an API, for example. Now we'll talk about training data, so attacks during the training phase. And training data poisoning, I think, is a really practical and likely attack, and something most machine learning developers should be thinking about these days. And so go back to your feature engineering, garbage in, garbage out. There are a lot of different ways to do training data poisoning, but maybe the easiest way to think about it is adding certain triggers to images. So if we kind of add these pixels in the bottom right, we can teach or we can set up the training loop such that it learns this pattern of these pixels in the bottom right instead of the 7. And that would allow us to control the output of the model. You could also do something like changing the labels. If all of these pictures are put in with labels of 2, then obviously the final output would be poisoned. So with these concepts in mind, let's talk about how we assess risk in real systems. And I know I've said this several times, but it's really important to think about the context. So for facial recognition, if we're talking about logging into a computer, maybe that's okay, or maybe the benefits outweigh the risks. It would probably depend on what this computer has access to. But if we're talking about some sort of like targeting Terminator bot, maybe that's not okay. These models and systems are increasingly used to enable cyber physical systems like robots. And so now the harm goes from giving the wrong answer and whatever harm that may generate to actual physical harm. But it's not just robots. These systems are increasingly trusted, especially by people who are not familiar with the underlying technologies, and that can generate, real harm, just outputting numbers that are later processed into text. So think about what a model is used for, and that should help you identify how you should be assessing the risk. If you're just doing some benchmarking and no one's ever going to have access to your model, maybe you don't need to spend that long thinking about security. If you're going to publish the model and someone may use it or perform an assessment on it in ways that you didn't intend, maybe you should be performing some sort of risk assessment on the reputational harm, maybe the data that was included. If it includes some proprietary data, remember that these models are compression of the training data. You might want to perform an assessment there. If you're hosting a service, obviously you want to check for bias and performance. You need to assess the risk of the model being stolen, as I highlighted earlier. And the integrity of the entire system. Can the integrity be modified? And then ultimately, if it's controlling a physical system like a robot, or a car, we need to perform a much more robust assessment of the risks. Keep in mind that the training data matters a lot. So MNIST is this publicly available data set, kind of one of the first big image data sets of handwritten numerical digits. So people would develop image classifiers. Is this image a 0 or an 8 or a 7? And so if you use this and only this to build your model, you probably don't need to worry about training data leakage or data privacy, because people could just go download this. They don't need to use your model to do it. Unless maybe you exist in this really interesting security context where you're using the model now to validate check images. Now, your concern should be higher, because an attacker would have access to this data and maybe could figure out, oh, someone who trained using this specific data set, if I draw my 0 in this specific way, it looks like an 8. And now, instead of $0, the check says $8 or something. Those are kind of curated data sets. Lately, there's emerged these internet scale data sets where someone will scrape the entire internet and provide it as a training data set for some of these really large models. And there are concerns with these. They include things that you would find if you scrape the entire internet. And a lot of that, going back to garbage in, garbage out, is not something you want your model to learn. There are also potentially, safety or ethical or legal reasons that you may not want or may not be allowed to hold or use this data set. And so that's something you should consider. So when we talk about evaluating data sets, a public data set or something scraped from the internet could have all sorts of backdoors or intentional poisoning attacks, or just data that shouldn't be in the public domain that now you may be responsible for if your model starts outputting it. If you start using algorithmically generated, so synthetic data, it can be very useful, especially for prototyping, but there is kind of this idea of model collapse or reduction to the mean or echo chambering that can reduce your performance. And then once you start using privately collected or sensitive data, which is what a lot of organizations may do to kind of differentiate their products, now you have this risk of data leakage or inference, and that private data potentially being exposed that you need to assess. In conclusion, the domain is still largely academic. The attacks have become more and more practical over the last couple of years, but most organizations don't have dedicated AI or ML security teams. And so if you are a builder, a data scientist, or a machine learning researcher, you should take ownership of the security of your product, because it's not necessarily true that any security professionals are going to help you have the expertise to do it for you. So remember that models implicitly expose training data, and you should kind of figure out how much you care about that. Maybe it doesn't really matter in your context. They're complex and unpredictable, and most data professionals are going to kind of know that inherently. And they're difficult and expensive to patch. So what can you do early in the process to provide some assurance to yourself and your organization that you're going to get it right? And remember the 3 points: garbage in, garbage out, don't anthropomorphize, and context matters. It's a tough thing to learn more about machine learning security. So here are some resources to potentially help. So the DEF CON is a large security conference that happens in Las Vegas each year. That's organized into different villages. The AI village has a fairly active Discord. Each year they put on some workshops. There's a virtual capture the flag competition held on Kaggle each year, put on by Will Pierce. It's a phenomenal way to kind of enter and start interacting with some of these challenges in Python. LLM security is a subset of machine learning security that has gained a lot of focus, jailbreaks and prompt injection and stuff. And this website's a great way to kind of keep up to date with that. A lot of the academic attacks I discussed and mitigations and ways to generate metrics for evaluation are included in the adversarial robustness toolbox, which I linked here. You'll find other machine learning attack and defense libraries, and often they're built on the adversarial robustness toolbox. The adversarial robustness toolbox repository also has a bunch of example Python or Jupyter notebooks. And so I think it's a great place to kind of get started as you want to learn more about these sorts of attacks and defenses. Here at NVIDIA, we've developed an AI security training that we've given at a couple of security conferences in person. We're currently working on porting that to our Deep Learning Institute, our online learning platform. And so that should be available here later this year. And then as you're kind of working through establishing standards in your organization, or want kind of a more formalized way to discuss these risks, NIST just came out with a taxonomy and terminology for attacks and mitigations that might be useful to you. You're also more than welcome to reach out to me, and I can maybe steer you towards some other resources depending on your questions. Speaking of questions, thank you for having me today. I think we have plenty of time to answer any questions that may come up.
Thank you, Joe. We do have some questions, and so I will read the first one. And the first one is the speaker related with this research by NVIDIA? There's a securing LLM systems against prompt injection blog. Do you know?
I am. Yep. Yeah. So if whoever asked that question, wants to contact me offline, I can talk more about that research.
Okay. And then the next question is, what is the overlap between machine learning security and AI ethics?
I think that's a phenomenal question. So we see terms like ethics and fairness and safety and security. And at the end of the day, and this is just one person's opinion, these are all characteristics of an AI system that a user or an organization may want to assess. We want to assess how ethical the model is or how secure or safe. And a lot of times we can use the same sorts of techniques. So I talked about like inference style attacks. Go back to the slides here, right? Where we recover some training data. I talked about this in a security context, but it could be really useful from an ethics context as well. If we want to understand if all the desired, classes were represented in this model, this is the sort of technique we might use to do that. And so, at the end of the day, I think organizations or model builders need to define characteristics they want their models and systems to have across trustworthiness or ethics or security or safety. And then all of the techniques I discussed here can be used to help measure those characteristics.
Thank you. The next question is, if we compare open source models versus closed models, what would you say in terms of trust? Could we trust more the open source ones since everyone can see or detect their vulnerabilities, while the closed ones, companies possibly hide them?
I think that's a difficult question. It kind of stems back to the open versus closed source discussions in traditional software. In general, I think the more visibility you have into a system, uh, the more you can convince yourself about whatever characteristic, the trustworthiness, ethics, security, or safety. Um, and so that would tend to favor open source models. There's also been kind of a debate about whether most of the models released today are truly open source versus kind of being publicly available. Um, but in general, I think what you want to do is define a set of characteristics that you're concerned about and a set of tests. And that's the best way to perform your assessment, regardless of whether the model is publicly available, open source, or closed source. You need to be able to run that suite of tests because you can't really examine the weights of a model manually or through static analysis the way you can with traditional code to reach the same sort of assurances that you can with traditional software.
The next question is, what do you see in the future development of machine learning and AI in 2024?
Ooh, what do I see in the future? That's a big question. I think LLMs have obviously been very popular. There's been a big shift towards multimodal. I think we'll see a lot of developments in multimodal applications in 2024. And I think what we'll start to see, especially have started to see already, maybe with mixture of experts and stuff, is that instead of one large model, we'll start ensembling together or using smaller, more purpose-built models. And that's, consistent with what we saw with other types of machine learning is that, no matter how big you make the tree, using an ensemble of trees is better. And so I think that sort of ensembling is step will start to emerge in 2024.
Okay, the next question is, how does one get into AI security? If I'm a product manager with a low to medium level of MLOps knowledge, what are some paths I can get to work in AI security, and what kind of positions should I be looking at?
I want to make sure I address everything. Is that over in the chat? I want to make sure I kind of read that and address the whole.
Yeah, it's in the Q&A. It should be the question at the top.
I see. Okay. Um, okay. Yeah. So I think, especially for product managers, I wouldn't encourage you to focus on machine learning security. That's a very specialized field, and instead broadening the aperture to managing machine learning products, where as the product manager, you can emphasize certain characteristics like security or trust or ethics. I think that's the best way, because as a product manager, you're helping define the requirements, and helping ensure that those requirements are met. And that would be the route I could encourage you to take.
Okay, the next question is, how long before we start seeing job titles with machine learning and AI security in them?
It's already happening. And, I got one. I'm starting to see them grow uh, at the big AI companies, obviously. And so what it'll kind of start in the bigger tech companies. There are roles at NVIDIA, Amazon, Salesforce, Meta, OpenAI right now. And then all the large security contracting firms also are looking for uh, AI focused contractors.
Thank you. The next question is, which is the best virtual online platform to train the model from, since GPU is kind of expensive?
I don't think I can answer that one directly. I don't want to endorse any specific platform. All of the cloud providers have some resources available. What I'd encourage anyone to do is work on prototyping at a small level and only scaling when you have some kind of assurance that what you've developed is promising. Um, so use free tier GPU and access when you can, and then once you start to have a promising prototype, scale up.
The next question is, how do we enforce the security measures against some of the attacks discussed?
Sure. A lot of that depends on your organization and the existing structures in your organization. I've seen the most success when uh, these defenses are assessed as part of a normal assessment pipeline. So if software normally goes through a security review, while it's going through that security review, assess these characteristics or the defenses against the attacks we discussed. It's also important very early in the process, kind of in the ideation phase, or we talked about requirements generation, to maybe do a threat model at that point. So write down, hey, here's the product or service we want to build. Here's where we're going to get our data. Here's what the final API might look like, and maybe some user stories. And then take it to someone who's experienced in this domain who can point out potential pitfalls that exist along that route, so that you can build the defenses into earlier in the process.
Thank you. One thing that I'm going to share in the chat is we did have a speaker recently about another topic in security, which is an overview of InfoSec. And I'm going to share the link in the chat right here. There's a lot of Q&A at that, and so there is a lot of information there about security. You may want to check it out as well. And another thing Joe and I were speaking earlier, and we're in a few months we're planning to have another webinar on how to get into security. So just keep an eye out on the Meetup group. There's no date set yet, but sometime in the future. If anybody has any other questions, now is the time to ask. And yeah, I'm going to leave that. I don't know, Joe, do you have any other closing words?
I don't. Thanks for having me. I, love the mission of Data Umbrella and what it represents and what it can mean to the community. And so I'm happy that I had this opportunity to give back.
Great, thank you. And so we'll also get a link to the slides. And so once the video is posted, we'll post the video within 24 hours, and we'll post a link to the slides there as well. Yeah, thank you everybody for joining us.
Thank you. Have a great day, everybody.